So where is everybody today? Was last week that bad?
It's gonna snow today, yeah.
Well, it is going to snow today. But it's not snowing yet.
I know.
Oh, I got to turn this around now, huh? Turn this around. All right. Who's excited about robots? Really? You gotta be more excited than that.
Yeah.
So you guys know we have 3 TAs for this class. Did you know that? Who remembers first day class? Vaguely. There was a kid sitting in the back. When we formed groups, there was a kid that didn't join any of the groups. He's the 3rd TA. Except I didn't know until after that class was over when he came up to tell me that he's like the TA in training. He's hoping to become the TA next year. And there's a weird thing with the way the credits and stuff that was available. But I thought that was kind of funny. We're talking about, turn down this, is amplifying my voice, right?
Yeah.
It's really weird for me. You guys can all hear me? Okay. Tell me to speak up if you can't hear me. Don't make me turn on the speaker thing. Oh wait, no, I'm gonna need volume. We're gonna play a YouTube video in a second. Alright, so this is what's gonna get me excited about talking about robots today. And so,
Oh, great song.
here it is. Here it is. This is what's gonna, yeah, not so much the McDonald's ad. It's gonna get me excited. You know, McDonald's is a manufacturing company, right?
Oh, yeah.
Alright, so this is, and everybody's gonna dance. Yeah. You guys gonna dance? Where'd all the girls go? They heard we were dancing today. This is like junior high. I got one. Alright, before we start talking about what's a robot, we'll let that play there with no volume. Before we start talking about what's a robot, what do you guys think about the exercise we did last week? In the process of going through it and figuring out how to automate that system? Who thinks that their idea was the best idea that was presented? You might think so. Which one was yours again? So you had a 6-axis robot.
Yeah.
It was picking things up, putting them down, picking things up, putting them down, picking things up, putting them down. How much did it cost?
Probably an underestimate. I was thinking it was like 60 grand.
You think about 60 grand, maybe. That's probably pretty low. For acquiring the robot, programming the robot, setting the robot up, testing the robot, fixing the broken program, testing the robot, fixing the broken program. So that's probably a little bit low. So you thought yours might have been a good solution. Everybody else thought somebody else's was a better solution. Which one did you think was the best solution?
I mean, depending on their budget, probably either robotic arm or
Robotic arm. Was there just one that had a robotic arm?
We had one for a portion of our.
Yeah, that's what I thought. There's 2 that had robotic arms. So you think theirs might have been the best? How about, what do you think was the best solution?
I don't know, maybe I'm a little too iron horn, but I like the bowl feeder one.
I totally like the bowl feeder for orienting the parts.
But yeah, getting the parts in the basket, I didn't like how we did it because there were too many variables. The bearings like a little bit off. You need different.
So the first thing that I envisioned, right, because we're engineers, right? We jump to the solution as soon as we think we might understand what the problem is. In fact, as soon as we think we understand what the problem is, we stop listening to the customer usually. Is that true? Anybody experience that? Anybody caught themselves? Stop listening, because I understand what the problem is, and all I want to do is solve it, because I'm an engineer. Anybody read the book, Men Are From Mars, Women Are From Venus, or is it the other way around? Men Are From Mars, right? Anybody ever read this book? Anybody know what it's about? Heard of it? So it's, some marriage counselor wrote this book, and he wanted people to understand that not all people think the same way. And so in his mind, it was written by a guy, so I don't know how he has any understanding of the mind of a woman. But he said that women, when they talk about stuff and they complain about stuff, they just want to talk about it. And men, when they hear complaints, they want to jump to solutions. I don't think it's men and women that do this, but certainly engineers, when they hear problems, they want to jump to solutions. The book never worked for me because my wife is also an engineer. Sometimes when she talks about stuff, she wants to solve the problem, right? And I guess I have my feminine side. Sometimes I just want to talk about the problem. So, right. So, my first vision, when they were describing what they wanted to have, was some sort of a vibratory bowl feeder or something that was going to orient the parts, put them in some kind of a chute, right? Have them slide down a chute, and you guys, a lot of groups had something like this where it slides down a chute, and then I was going to have an arm that would raster scan back and forth across, like this, and it would just open a gate and pop the bearings out into the basket as needed. And it was going to have to, because the back of the baskets are a little bit different, so it was going to have some mechanism of knowing how far in and out to go. But I basically wanted to mimic an arm, a person's arm, except having the bearings sliding down the arm, and I just place them, right? And so it wasn't a 6-axis robot, because you didn't need that many degrees of freedom, but it was a custom-built robotic arm kind of solution that I envisioned. That's the first thing I envisioned. Then we started talking about budget, and the fact that they thought $50,000 was too expensive. And I started thinking about the fact that, well, I'm not going to build that for less than $50,000. There's no way that I can build that for less than $50,000. So that solution's not going to work. So I started thinking, is there a cheaper way to do it? Can I do it with cams and mechanical followers instead of vision systems? Because my first thing was like servo motors and vision systems, and I wanted to build an arm. And I realized that's not going to work. So who took a step back and looked at the problem from further away? Because that's one of the first things that I try to do when I get stuck in my solution, especially when I'm so solution focused. When I start hearing the problem, I'm very solution focused. So I do this. And so I took a step back. I said, what's the real problem here is that they need them oriented in the certain orientation, and they need them stacked in the box, in the basket. What happens upstream in the process? So upstream in the process, the parts are coming off a lathe or a grinding machine and getting thrown in a box. Somebody picks it up and handles it at that moment when they throw it in the box. The operator picks it up and handles it at that moment. When the operator picks it up and handles it, they have the orientation, they know it. I mean, it's one or two, right? They have the orientation. And so my proposed solution to them had nothing to do with automation. I said, move the baskets to where the lathe is. Get more baskets so you can have a continuous flow. Have the operator at the end of the lathe filling up the baskets. Now, you gotta move them because it was a different physical facility, it was across town. So there was a group that had the idea of like the cardboard liner thing to slide the pieces in. Which group was that? Are they here? So you guys that had the idea of the cardboard liner thing, so my solution involved having those kind of things. Because if you drive it in a pickup truck across town or in the back of a box truck across town, the thing's going to shake around, and we had to have precise locations. So you keep these liners, the operator drops it in the spot as he takes it off the machine. It goes across town. Before it goes into the furnace, you pull the liner things out. Good to go. That was the proposed solution.
You got paid before you told them.
Yeah, no, I learned a lesson, and I should have known it before then. If you're going to do consulting work, and this is an important life lesson for anybody that thinks they might want to do consulting work, you cannot tell the customer the answer before they've agreed to the purchase order price. Because once you've told them the answer, they have very little incentive to pay you. And the other thing I learned about consulting is you don't get paid for knowing the answer. You don't get paid for figuring out the answer. You don't even get paid for telling the customer the answer. You only get paid for mailing them an invoice. So, this is my lessons on consulting. But, so my solution involved not using a robot. I like the way we thought about this, and I like this example as a way to think about how to automate a system. Before we start talking about what is a robot, because a robot is a tool for automation, right? We can use robots as a tool for automation. A robot in itself is not an automation system. It's going to have other components that work together with. In fact, it has to have some process to automate. But the first and most important question that we're going to ask isn't, how do I automate this? The first and most important question you have to ask is, should I automate this? There's a famous quote from Bill Gates that if you automate an inefficient system, you just have an inefficient system that works faster. Right? So you can be inefficient more quickly, which then helps you lose money faster if you're losing money from your inefficiency. So how do we decide, first off, how do we decide if we're going to automate? What are the things, and this is a management decision, right? Who decides? Does the engineer decide if we're going to automate? The engineer may suggest it, but the engineer doesn't usually get to decide if we're going to automate. It's some management decision, some upper management that decides if we're going to automate. So, what do they need to consider when they're deciding whether or not to automate? Come on, turn it on. Here it comes. So what's the first thing I have to consider if I'm thinking about automating?
Largely financial.
All right, so you say it's largely a financial decision. It'll be there when it comes up. Yeah.
It'd be like if they're trying to scale their business.
So is it truly always about finances and whether or not we should automate? Certainly there's got to be a financial component to it. Is it ultimately only about finances?
There's a component of finances and
So I think if you want to make it always about finances, there's always a way that you can trace this back to dollars, right? Right? What's the saying? Time equals money, right? Who's seen the joke where you can prove mathematically that money is evil, right? This is the thing on the internet. You can prove it mathematically. Because so what? Money is the root of all evil. No, it's that you can prove that women are evil. Right, you prove that women are evil. Yeah. Anyways, fun joke in a room full of guys because all the ladies stayed home today. I'm sure the ladies could prove that men are all evil, probably with fewer steps than it takes to prove that women are all evil. Okay, so there's a way to trace everything back to finances, but so we want to grow the company. So you want to grow the company. We know we've got to keep track of the finances. It has to make financial sense to do it. But why do we decide we want to automate something? Yep. So, because how could you grow the company? First off, how do you measure growth of the company? Yeah.
Maybe like how many employees you have.
So we could measure the size of the company by number of employees. And certainly through the Industrial Revolution and everything, the number of employees was a significant metric for how big the company is, right? And we still classify companies like this in the US, right? We have small and medium-sized companies. Those are companies with less than 500 employees. We have large companies, those are companies with more than 500 employees. And so that's how the United States, in its sort of census accounting mechanism, breaks down those companies. Now, the small and medium-sized companies, this less than 500 employees, to me, 500 employees sounds like a lot. Most of those less than 500 employee companies are actually less than 20 employees. There's statistics about this, something like 80% of them are less than 20 employees. So we've got small companies, we've got medium companies, we've got large companies, and then we've got what I like to call the micro companies. That's when it's one employee and it's the owner. Not sure you call that a business, but I guess, I don't know. So number of employees, how else do we count growth in a company? Because the number of people employed in manufacturing has been going down steadily over time in the US. However, the amount of manufacturing revenue that's been generated every year goes up every year. So we're doing more manufacturing in the US with fewer employees year after year after year. So number of employees is a way to measure growth. How else do we measure growth?
Assets.
So assets. You are the finance guy, huh?
I have money in the line, but I don't know.
So we should all have money on the mind all the time. Assets, and so these are things like capital equipment. Real estate. Right, intellectual property. So patents and things like that, the company owns. It could be proprietary information. Like the ingredients that go into the special sauce in the Big Mac. The ingredients in the recipe for the Colonel's chicken there. Right. Right, so those are proprietary things. That certainly is an asset. One of my favorite professors from graduate school was a business class that I took. It was, I forget the class. The class was like strategic thinking 101 or something like that. Like, how do you think about big pictures in a company? This guy had been a bigwig, one of the C-level executives at IBM before he taught this class. And he knew how to think about big things. But one of the things he said every day was most companies forget that their number one asset goes home every day at 5 o'clock. And that's the employees, right? The people that have specialized knowledge. So it's an important thing to remember. But how else do we measure companies' growth?
Revenue.
So, line. And right, I'll just skip right to top line revenue and bottom line profit, right? If we increase sales, then the company's growing. If we increase profit, then not only is the company growing, but the investors are happy. These are really the ways that you measure the growth of a company. So if we want the company to grow, we've decided we're going to automate, and we need to consider these things. So are we automating to reduce our number of employees? So why do people automate? Why do people buy a robot? One reason might be cut cost, right? That's obvious to people. We might do this to cut costs, and we're going to cut cost by, right? So we're going to cut cost because we want to reduce the number of employees that it takes to do this. Now, if we're really forward thinking, we don't want to fire the people. We want to have them start doing something more valuable, right? So if we're really forward thinking company, we are cutting costs in this operation by reducing the number of employees it takes to do this operation so that we can have those employees go do something upstream that has more value. But if we're short-sighted and our company's managed by a bunch of accountants What they wanna do is get rid of employees because salary is expensive. Labor's expensive. And I don't care if you're in a low-cost labor region either. Labor's always expensive here. So we wanna cut costs. Why else do we choose to automate? So we choose to automate to cut costs, because we want the company to grow, and if we cut costs, we may not be growing by adding employees, but we are growing, well, one, if we automate, we have to purchase capital equipment, right? Almost never can you automate without purchasing capital equipment. Value of our assets goes up. Now, our debt probably also goes up too. But it can help us reduce cost on employees, profit. So bottom line can go up in this automation. So cut costs. What else do we automate? Yeah.
Well, make process faster.
Why would you want to make the process faster?
So you can do more of whatever.
I'm not saying you don't, I just want to know why.
So you can like do more of whatever you're doing per day.
So that you do more of whatever you're doing per day. Under what situation do you want to do more than what you're doing per day? Yes.
If the demand for whatever you're doing is exceeding.
If you cannot make the parts as fast as your customers want to buy them. So if the demand exceeds capacity. So going faster does not make us any more money if the demand does not exceed capacity. It may free up time on that machine to do something else, but at least for that component, for that part, it doesn't make us any more money. Oh, so speed up the process. What else do we automate for? Why else do we automate? Cut costs, speed up the process. Both of those are in order to drive up profit, right? I mean, speed up the process could drive up top line and bottom line. Why else do we automate? Yeah,
To battle competition, I guess.
say again?
To like the competition,
To fight the competition.
like the sense. So if your competitor can make this product in a week and it takes you 2 weeks, if you automate.
So that either comes down to cutting costs or speeding up the process though, right?
Right.
Right, so it may be you have to do it because your competition has automated, they've sped up their process and now they're taking a bigger market share because they can make the parts faster than you can. So that's possible, but I think that's a rationale for wanting to grow, is so that you don't die. Yeah.
Automating could potentially increase the quality of the product.
All right, so sometimes we want to automate to increase quality. So, did I tell you guys my golf club shaft story? Yeah, perfect. You guys all look confused. So several years ago, I was working on a process to automate an inspection system. Now this company makes golf club shafts, right? So not the golf clubs themselves, just the shafts that get attached to the head. And they manufacture these golf club shafts. And when I'm talking to the VP of engineering, I think it's VP of engineering that I was talking to, and he says, all right, so he posed a question to me. He says, what gets the golf club from the rack to the cash register? Right, so you go to the store, they're on display. What gets it from the display rack to the cash register? He says, people pick it up. They wiggle a little bit with it, right? They swing it back and forth. It's got a feel to it, and they look at it. It is that looking at it that actually makes the decision. It's like, yeah, I want to have this in my bag, and I walk over to the cash register and I buy it. It's actually the surface texture, the finish on the shaft that people are looking at a lot of times there. I mean, maybe they're looking at the head, but that shaft is the big long thing that they get to look at. And so they have determined that if they could tightly control the surface finish on their golf club shafts, then they could sell more golf club shafts because their customers would sell more golf clubs. And they noticed, and so they monitor this pretty closely. They noticed a problem. every day, after the Red Sox would lose, rejection rates went way up. And so does this mean our operators are making crappy product after the Red Sox lost? They actually determined that it was Joe. Joe's the guy at the end of the line that did this and said, yeah, that's a good one. Put this in the box. Yeah, that's a good one. Put this, yeah, no, that one sucks. Rework this one. Yeah, that was a good one. Put this in the box. Joe sat at the end of the line. Joe was pissed the day after the Red Sox lost. Therefore, rejection rates went up. They needed to replace Joe with some mechanical system that didn't care who won the baseball game. Right, so you can increase perceived quality, not just quality, by automating that system. All right, so we automate to increase quality. And so how, in a more generic sense, how does automation increase quality though? Those are a pretty specialized example of increasing quality with automation. Yeah?
Makes it more consistent.
It makes you more consistent, right? If you've got a very boring job that nobody wants to do, it's easy for the operator to lose focus and screw up. And so it's harder for the robot to lose focus and screw up. Robots screw up for totally other reasons, not focus. So we want to increase quality. We want to cut costs. We want to speed up the process. We want to increase quality. Why else do we automate? Why else do I buy a robot?
Increase worker safety.
We want to increase safety. And so, when we talk about robotics, we often say we want to automate, we want to use a robot to do the dirty, dull, dangerous jobs. There's 3 Ds. Dirty, dull, and dangerous. If it's dirty, dull, or dangerous, it's a suspect for using a robot to replace the operator. And we didn't talk about dirty here, but it really, I think it comes into increased quality. The operator doesn't want to be in the dirty environment. If it's a dirty environment, it's probably also a dangerous environment. And so this is why we build robots to go inside pipelines and inspect the interior of the pipelines, to go outside pipelines. This is why we build robots to go inside confined spaces and inspect the inside. When I was, years ago, I worked at a nuclear power plant. I was an engineer at a nuclear power plant. One of the things, and I was there during a refueling shutdown, one of the things I got to do was I got to be the guy that got all dressed up in the yellow suit and taped the gloves on and everything like that, respirators on, all taped up to the face and everything. I get to ride in a little rubber raft around the torus of cooling water that goes around the nuclear reactor, riding around with a grease pencil, marking the spots that needed to get repainted. Now, I was the engineer, so I get to go around a little rubber raft and mark the spots, right? Somebody else had to go in there with a freaking paintbrush and a wire brush, do the painting. Man, it's cool to be an engineer, right? So, but wouldn't it have been safer to have a robot be able to not only notice the spots, but do the painting? Yeah, that would have been better. But then I wouldn't have that cool story about the radiation suit and the rubber boat. So I get to have this cool story. Robots aren't able to tell stories. We need better robots. Robots can tell stories. These are the primary reasons that a company wants to automate. From management's perspective, what is the difference between automation and outsourcing? If this is what management wants to do, what's the difference between automation and outsourcing? All right, that's going to be the homework problem for this week. Hey Ryan, write this down. This week's homework problem is to answer the question from management's perspective, what's the difference between automation and outsourcing? These are the reasons we want to automate. All right, now we're going to specifically talk about automating with robots. So what's a robot? This is really no fun for me if you guys don't talk. I know what a robot is. What's a robot? So we've decided the purpose of using a robot is to automate something, but what makes it a robot? What makes it a robot instead of just an automation system? Because we have a program in robotics here at WPI. We don't have a program in automation systems here at WPI. Why do we have a program in robotics instead of automation?
I think a robot is a mechanical system that can make decisions.
A mechanical system can make a mechanical system that can make decisions. This is sort of like a person. We're a biomechanical system. And we make decisions. They're not always good ones, but we get to make decisions, right? We get to choose. Is a robot a mechanical system that can make decisions?
I would say it's an electromechanical system. That can make
All right, you wanna be more specific. It's an electrode. Electromechanical system that can make decisions. Is a robot an electromechanical system that can make decisions? Yes. Is a robot an electromechanical system that can make decisions? You willing to go with that? You say it depends how much it costs? Is a robot an electromechanical system? You wanna add something, you wanna take something away?
Did you say that like that phone thing was a robot too? Or no?
Does it have to be an electromechanical system? Could it possibly just be a system? Right? If Jason, who likes to sell me home security systems, is a robot, and we all call him a robot, right? I got a robo-dialer, right? Robo-dialer isn't a finger that's pressing buttons on a phone. Right, you guys know that? But I think I know what I'm gonna be for Halloween next year. Robo-dialer is not, wouldn't that be cool? Because they have robo-writers, right? They actually do have robots that will write handwritten letters. It is statistically proven that you're more likely to open a letter if it looks like it was hand addressed. And you're more likely to read the letter. Now, who does these statistics? People that send direct mail to you to try to get you to buy stuff. These people know numbers. And because of that, they've invented robots that will write your letters by hand. Not only that, you can train them to do your handwriting. And it will write your letters by hand, and you can send out 1 million letters today without having to, break your wrist. What were they doing there? They were trying to speed up the process, right? I suppose maybe they were trying to increase safety, because for me to write that many letters, I'd get carpal tunnel. So is a robot a system that can make decisions? Yeah.
How does it make those decisions?
How does it make those decisions? Oh, decision matrix, I don't know. How does it make those decisions? Is that what it is? Or does it have to be electromechanical? Is Jason not really a robot? I actually think Jason is a robot. But a system that can make decisions is insufficient to describe what a robot is. So what else does a robot have to do? How does it, did you mean to ask the question, why does it make decisions? Instead of how? Because we could have some sort of logic algorithm in the programming that helps it make the decisions, right? So it does not have to be a sentient life form to make these decisions. We can develop a matrix where if this, do this, if this, do this, we can guide how the decision gets made. And we probably should be, if we're programming the robot, we should be guiding how those decisions get made. But in order to make decisions, it has to be able to have input. It has to be able to collect data from which to decide. And it has to be able to have output to tell you what it decided. Because it would be pretty pointless for it to decide and not tell anyone, right? And not take action. So I think it has to have sensors or input for input to the system, and it has to have some means of interacting with the environment to output the decision. Then, of course, the common robots that we think of are the ones from the Jetsons, right? Here's George Jetson, his wife, what's his wife's name? His wife, no, Judy's the daughter.
Joan?
I don't know, but Judy's definitely the daughter.
Oh, it was Joan, maybe?
Joe Jetson. No.
Joe,
No,
that's
Joan
Joan Jett, the Blackhearts.
Yeah.
That's what you're thinking of there. And we could totally go into a Joan Jett thing too. Okay. So the most common robots that we think of though are these science fiction robots, right? The walking, talking robots that either carry guns and kill us or enforce the law or go rogue and take over the universe, right? We think of those robots, like if somebody says robot, that might be the first thing that comes to your mind. Unless you work in manufacturing or you watch a lot of financial news. Because when they talk about robots, they're not talking about the science fiction killer robots. They're talking about those yellow and orange robotic arms that are doing this, right, moving stuff around, and welders on the end and stuff like that. My friend worked at these companies that get a robotic system and then attach it to the bowl feeder and then install it at the company like the bearing race people that we talked about. The companies that do that for a living, they're called robotic system integrators. And that's sort of the class of business that they are. So a friend of mine worked at an integrator, and they had to go in, somebody else had built the system, they had to go ahead and fix the system. So there's a robot, it was a 6-axis robot. I think I want to say it was an ABB or an Asea, which ABB purchased Asea, so it's just an earlier version of an ABB robot. I think I want to say that. But they programmed it poorly. And so on the end of it was a plasma torch. You guys know what a plasma cutter's for? Plasma torch? It will allow you to cut through like 4-inch thick steel plate with plasma, high energy plasma. It vaporizes the steel. And we have one in the Washburn that's smaller than that. It can't go quite that thick. But plasma cutter on the end of the robot for cutting these steel plates into shapes. That's pretty cool. Except plasma cutter cut the control lines to the robot. But not all the way through, just some of them. And so now you got live plasma torch and robot going crazy in the work cell, right? So they killed the power, shut it off, right? There was a solution. It wasn't like Skynet awakening. There was a solution. But, so his company had to go ahead and fix the problem. One thing was, don't route the control system lines, where the robot's gonna be cutting with plasma torch. Yeah, so we've got inputs and outputs, system that can make decisions. And so we program that decision matrix, but this is really what a robot is. The ones we typically think of in manufacturing are these 6-axis arms, or we've got, there's a bunch of different styles of robots in let's call it industrial robotics or manufacturing-oriented robots. And those all have one purpose. So a robot used in manufacturing, all of them, no matter which robotic system it is, the one with the plasma torch on it, the one that we saw some pick-and-place robots in some of those videos earlier where they're like moving, it was like a demo, right? They were moving checkers back and forth in a Chinese chessboard or something like that, marbles. Then there's the one, there was the one that was sorting, that was an automation system that was sorting marshmallows. We had one that was picking stuff up and moving it. So, the one with eggs, right? You're picking up eggs and moving them, right? So every single robot that's used in industrial robotics has one function. They all do the same thing. They have different mechanical systems to get them to do the same thing, but they all do the same thing. They position, orient, an end effector, position, orient, and operate an end effector. How do you spell effector? I think it's 2 F's. Position, orient, operate, end effector. It's probably 1 F. But the purpose of the language is to communicate. Do you guys know what I mean? Perfect, I communicated, it doesn't matter how I spell it. position, orient, operate, and end effector. So let's look at our plasma cutter, right? In order for that plasma cutter to work and do the cut that you want it to do, the tip of the torch has to be at the right location when you turn the torch on. And it has to move at the right velocity in the right direction when the torch is on. And when it gets to the end of the cut, it has to turn the torch off before it cuts its control wires, right? And it has to be at the right position and the right angle. A robot with a welder on it. Anybody ever welded? Right, like stick weld or something like that, or TIG, yeah. So when you're welding, you gotta have a feed material that comes in, right? That feed material has got to come in at the correct rate. If you feed too fast, it doesn't work. If you feed too slow, it doesn't work. So that feed material has to come in at the correct rate. Not only that, it has to be at the right position above the spot you're welding, and at the right angle. If you tip the head like that, it's a different weld than if you tip the head like that, right?
Yeah.
And so as you go along, in order to do the welding, you have to position, orient, and operate the end effector. You gotta turn it on and off. Let's think about a pick and place robot. I got my thing over here, it's gotta go over here. If I'm let's see, can I do 6-axis? I got one. Okay, I got 1, 2 degree of freedom. We'll do 1 arm. 3, 4, 5, 6. So I get 6-axis. I'm a 6-axis robot now, and I've got an end effector, which has, I don't know, like 12 degrees of freedom. So I can turn this way, bend this way, go like this, operate my end effector, come up, go over, come down, operate my end effector, right? 6-axis robot. I had to orient, now if I had to put this pen in something, or better yet, write with it, if I'm writing with the pen is just like the welding example, right? There's no difference between writing with a pen and welding, except for the heat involved. Welding usually has more heat than the pen. All industrial robots, this is what they do. A robot in general is a system that has sensors and inputs. It makes decisions, it has outputs, it can do that, it interacts. So it's a system that can make decisions and interact with its environment. We use robots to cut cost, to speed up, to increase quality, and to increase safety. I think there's one more reason we use robots. America, right? So you said it here, right? Because we can, because they're cool. I was gonna say, right? We use robots at WPI because they're cool, right? We want people to come here and see the robots that we're using because we want people to come here, right? So another reason, but it's like all these people are against robots. The world is against robots, right? Automated trucks. And I think automated trucks are cool. I cannot wait until I'm driving in my fully automated car, because you know what I'm going to be doing when the car's driving itself? Something else, right? Sleeping. I get visions. I'm not going to share all my visions. Right? So, but then again, I don't drive a car for a living. I'm not a chauffeur. Here's the thing about that topic. There's a whole class on that here at WPI. Did you know that? Like ethics of robots or something like that. There's a whole class you can take on this topic. I would, if you have free time in your schedule, I have never sat in on a lecture in this class. I don't know who teaches it. I don't know anything about the professor. The idea of that class, if I had free time, I would go take that class. If I had a free elective in my schedule, I'd find out if I could use that class to fill some requirement to take that class. Because I think this is, as engineers, we're engineers, we're talking about robots, doesn't matter what we're doing. As engineers, it's good to talk about how what we're doing impacts society. And certainly that topic impacts society I guess I just did my sales pitch for somebody else's class that I don't know anything about. If we can automate it, we will automate it. There will be no stopping it. There will be no laws that get passed that keep us from automating stuff. It may slow it down. Self-driving cars will be on the roads. Self-driving delivery trucks will be on the road. Self-driving delivery trucks that deploy drones to deliver your packages will happen because we can do that technology. And I guarantee you, if we can do that technology, we will do it. So maybe the best business to be in is the business that trains truck drivers how to do something else. Or the business of developing the technology to get rid of the truck drivers. Right, so, didn't matter how much the buggy whip manufacturing guys got upset when we started driving cars. We still started driving cars, right? It's the same thing. So, we've talked about what is a robot. We've talked about why we want to robot. I would say the most important question in developing an automation system, no matter where you go in the world when you're doing it, isn't how, it should. Is automating this the best decision right now? And don't forget, homework is, from the perspective of management, what's the difference between automation and outsourcing? Cool. See you guys, oh wait, we're doing robots tomorrow, right? So you guys do a lab tomorrow, you're gonna play with a robot. And by play, I mean program it and operate it. And play with a robot. Next week we only have one class, right? Yep. One class on Tuesday next week. And next week on Tuesday we're gonna talk about programmable logic controllers. That's a cool lecture. If you're watching from home, it might be fun to be here for that, because the last lab that you're gonna do is going to be programming programmable logic controllers. And going through the lab exercise will be much easier if you understand the thought process behind them and the idea behind how they work. I do know the guy that invented the PLC. I will tell you that he invented it on New Year's Day, 1969. Hungover, not wanting to go back to work the next day to do his job. And he's sitting at his kitchen table, hungover, New Year's Day, 1969, and he says, there's gotta be a better way to do this. And I guess there was, because he founded an $8 billion industry that morning at his kitchen table. Yeah, it's turned out on the agenda.
It's Tuesday, it says it's sort of live.
Oh, yeah, I gotta talk about the oral exam next week.
I have an interview that Monday.
So you got the filtration.
I guess you're gonna fail this
You got
class.
the drill.
But we don't need the class to graduate. We'll figure it out.
So we should figure it out together.
I think, did I have 2 days for oral exams? Or 1 day? Oh, the schedule. We talked about 2 days and 1 day, and I don't remember which we decided
I don't
on.
know if there's no that Thursday.
Thank you.
Stay
Yeah,
with
yeah,
it.
so, what
Give
we're
her a
gonna
copy.
do, and so next week, I'm gonna have everybody submit questions. Part of the oral exam is you guys will have to have to. And then on that day, we're gonna sit like in a circle. Still have no idea what we're doing. And we're gonna, I'm gonna take your question, ask him, for example, right? And then we're gonna discuss the answer as a group. So you can't, but you can't be there that day, because you're gonna be in Philadelphia. So,
If I take the
there's
bus at 11.
there's a solution to this. We'll figure it out. We'll just chat after you come back. Right, because it's oral exam, it just won't be as much fun, because it'll be less group.
Okay.
The group part is fun for me.
Alright,
So I gotta stop the video. But yeah, we'll figure it out.